Intermolecular forces, an overview. Intermolecular forces are the forces that hold molecules together. The tightness with which the molecules are held will determine what phase they are at each particular temperature. The stronger the intermolecular forces, the hotter you'll have to heat it to get it to melt or to boil. So this becomes very important in our later sections. Let's look at each of the intermolecular forces in more detail. In this video, we're going to be defining each intermolecular force and identifying the molecular forces that are present. We will also identify how intermolecular forces affect boiling and melting points. We'll rank compounds in order of boiling and melting points and explain them with more complex molecules. We will also identify common places that hydrogen bonding in IMF occurs and describe what about water's intermolecular forces are going to make it special and how this affects life on Earth. This set of learning outcomes is going to actually take several videos to finish. We're going to start here with just an overview of intermolecular forces, but I wanted you to know where we're going as we start working our way through these videos. First, let's define intermolecular forces a bit more carefully. These are the forces that occur between molecules. Note that they are not within a single molecule. Forces within a single molecule are either ionic or covalent bonds, or even intramolecular forces, depending on the situation. So for instance, if we have two water molecules, they have an interaction between the positive side of one molecule and the negative side of another molecule. This is called an intermolecular force. Specifically, it's a hydrogen bond, but we'll get into that later. Notice that the intermolecular force is between two different molecules, while a bond is between two atoms within a molecule. All of these intermolecular forces arise from a difference in charge, creating an attraction between molecules. Some of these partial charges are caused by a dipole, but they can also actually be charges, such as in an ion, or perhaps in the weakest of all, they can be an instantaneous dipole created just by circumstance. Those are the weakest of all. Each of these are going to have different names, and we'll discuss all of them in detail in their videos. We are going to go in the order that I think that students find from easy to difficult in terms of conceptual understanding. This means that we're going to start with dipole-dipole, then move into hydrogen bonding, which is actually just a very specific kind of dipole-dipole force. And then lastly, we'll do dispersion forces, which, though based on the same concept, is much weaker and can be in all molecules that we don't traditionally think of as having a dipole of any type.